summation, vector summation and integral calculus. Okay, so we are taking discussion. We have waged war for the summation. How to divide problem? How to divide problem into n different parts? Solve it part by part. How to divide? How to divide problem into n different parts? Then solve it part to part, and then sum it. If I have a big problem, if I have a big problem, then make it the way I give example. Generally I give example. Like if I have so many villages. This is the example I give. There can be many examples. I have so many villages in a district. There is a district. India is divided into villages, and then set of village they makes a block and then subdivision and a district. Now concept is that immunization has to happen. Now there is a medical organization and it would do immunization. So medical organization consider that every day it is going to 10 number of villages. Every day a medical team is going to 10 villages, and then it is giving medicine, immunization, or whatever the medical help to the people who are suffering from a particular disease. Okay. Now concept is that on an average, one village has a set of number of people. Or if a medical team is going, then it is going to 10 number of villages. Consider one village has 1,000 people. So 10,000 people it has to tackle. Now it will assess that 10,000 people when it has to tackle, then how much injection, how much medicine, how many doctor, nurses, or how many resources it has to take to tackle 10,000 people in one day. That is one idea. Every day 10 in a one district, typically 1,000 villages exist. In one district in India, typically 1,000 villages exist. If every day 10 villages are being encountered, if 10 villages are being served by the medical team, it will take 100 days to cover a district. Okay, why 10 villages? Because 10 villages has 10,000 people. 10,000 people. So 10,000 people it has to tackle. So 10,000 people it can tackle. Then for 10,000 people it is taking injection, medicine, so many things. And in a van with nurse and doctor, one medical team or a hospital, it is going village to village, 10 villages. The question is arising that is it a smarter way to do it? What do you mean a smarter way? The smarter way is, can someone find that in a particular village how many people are suffering from the disease? It depends. In one village there would not be anyone suffering from the disease. That is also possible. In one village all people are suffering from the disease. That is also possible. How we know that? Then we have to take, if in any particular village all people are suffering from the disease, then we will take for granted that we have to take medicine for everyone. That is not the case. There is what we are talking about. Now now we will do some mathematics to find out that every village how many people are suffering from the disease on an average. Every village how many people are suffering from disease on an average. If i know that if i know that then out of 10 villages, 10,000 people, probably I would be knowing that this many people are suffering from the disease. Okay, if I have capability of 10,000 people to tackle in one day, probably I can tackle 30 40,000 villages. I'm sorry, 30 40 villages in one day, because I know 30% or 35% people would be suffering from the disease on an average. If I know I can go three times, instead of finishing in 100 days for one district, I can finish in 30 days, 1 month time period. 70 days are saved. Okay, this is what. So how I can solve? Now I can take one village. Now I am taking some set of villages for gathering the data. I take one particular village, and in that village I take n number of people. I take n number of people. Okay, out of n number of people, how many people are suffering from the disease? I can denote as x. X number of people are suffering from the disease in out of n people. Okay, x number. X can be 0 to n. X can be 0 to n. Okay, what are the other data? In any village, consider out of all the people, p percentage are p, p, p percentage are suffering from the disease. So out of n, it will be if out of n, it will be n into p% people would be suffering from the disease. How many the how many people are living in the village? P% of it. P% of it are suffering from the disease. So that is the concept. P% are suffering. P% are suffering from the disease. Then then out of n, n into p% will be suffering from the disease. How to find average number of people in a village they are suffering from the disease. Now n number of people if I am taking n number of people I am taking, then out of n into p%, that many people. What is p? P is variable, that is not fixed. N is fixed. From a particular village, I take n number of people out to take the sample. I may take all people also, there is no problem. Or I take out 100 number of people out of the village. I know p% are suffering from the disease. What is p? P can be 0, p can be 100. That is not a fixed number. N number of person I am taking. Now there I am counting how many people have the disease. Okay, then I go to next village, then I go to next village, then I go to next village. And then on an average, I am trying to find out how many people are submiss. Something like that. I have n number of coins and I throw it. Then I see how many are coming as tail. I'm sorry, how many are coming as head. How many are coming as head. Then I throw the coin again. Then I see how many are coming as head. Then I throw the coin again and then see how many heads are coming. Then I would say, if I then after doing calculation, I would say when I throw a coin, then getting a head on an average, this much head I'll get on average. Okay, what it is means now I have to what I have to how I have to assess number of head will come. If I throw it, then one time I'll think the number of head is 0. If I throw it, then next time I'll think number of head is 1. Means probability of getting head in each throw is either 0, 1, 2, 3, 4 up to n. Then use the probability of the head. Getting head is how much probable it is. Consider it is p. P means if I toss a coin, getting head, it can be head or tail. Getting head is P. Similarly, if I have full village, in that P number of people will be diseased. If I take out one person, then getting disease on his face is P%. Similarly, here also. Okay, it is extremely difficult to solve it. That n number of coin if I throw, then how many head on average I can assess. But it is very simple to calculate coin by coin. Divide your problem into n different parts. If I am taking out n number of people from a village, divide into n different parts, means people by people. Okay, like here, coin by coin. In a particular coin, what is the average value of getting head? If someone knows it, then he can sum for n coin, n into whatever someone is getting, the average value of getting head, n into that much. That's it. Okay, dividing problem into n different parts, but we are using vector. That is different. Dividing problem into n different parts where we are using vector. That is different. We use vector to find out the solution for one part. If I have big chunk of problem, I divide into n parts. For one part, I try to find out the solution. Okay, and then we sum it for the all n part. There can be cases where n, if I sum it for all n part, it may not be perfect. It will be perfect if I make n tends to infinity. Then we go for the integral calculus. Summation to integral calculus is not straightforward. It is straightforward if summation is for the area strip, because integration fx dx calculate the area. Summation is summation of item, summation of n number of item. Each item, if it is an area, and all area are non-overlapping and contiguous, where the base of the area means height into base of the area tends to 0, and we have a height. Okay, means if I have fx, that is the height, into delta x, that is the width, where delta x tends to 0, and then we add for all the delta x up to n, where n tends to infinity. If this is the summation, if summation is in this form, summation I equal to 1 to n, summation I equal to 1 to n, and then function over x. If this is x-axis, let's take this is x1 and this is x2. Between these x1 and x2, I chop it into n part. Between x1 and x2, if I chop into n part, I have different subsection. One particular subsection has a width as x2 minus x1 by n. That is the width. Okay, what is the height at this point? This is the section number 1, 2, 3, ith section, nth section. If I take ith section, then what is distance from x1? Consider x1 is 0. What is distance from the x1? 0. For the ith part, if I know the distance, consider that will be x. Consider that is x. At this moment, what is the observation? Observation will be typically height. That observation, consider it is fx. Okay, then I write summation I equal to 1 to n fx. X belongs where x belongs to ith section. Fx or fx fx xi, function over, this is function f in bracket x bottom right, that is subscript I. Summation I equal to 1 to n means for all the sections, whatever the observation is, if I add all the observation, I get the result. Or in some scenario, in corner scenario, our observation in such a way that we multiply this observation with the width. If the ith section width is delta xi, then fxi into delta xi, plus fxi into delta xi, plus fxi into delta xi, plus fxi into. If I have something like that, summation I equal to 1 to n fxi into delta xi, fxi into delta xi is the area substrip. If I add all the area substrip, then it becomes fx dx. Fx dx is the net area. Then it can be directly converted into integral calculus. Summation I equal to 1 to n fxi delta xi. This is the, because this is the repeated summation of sub area, where delta xi tends to 0. This is typically be converted into integral calculus provided n tends to infinity. Otherwise, if I have summation I equal to 1 to n and fxi, it will not be converted into integral calculus. We have to apply some brain so that fxi will be converted into gxi delta xi. Height and width both are required to convert into integral calculus. Anyway, we are using vector now, and we are in very interesting situation where we are trying to find area. So we more or less we have calculated the area, but to clarify the area, we will go back to calculate the circumference of the circle again, where the circle radius is function over theta, and we will use length vector. We have demonstrated it. What is called a length vector? Length vector is a vector which represent a curved line. Straight line, we know how to have a straight line vector. If I have a straight line, gone. Okay. Okay. So if this is x-axis and I have a straight line, okay, what is length vector and how to find circumference of the circle? What is the speciality in the circle? This circle equation lies in r and theta. Consider this is a circle in xy plane. This is a circle in xy plane. This circle is centered at the origin. There is another circle which is not centered at the origin. This is the equation of the circle. Can someone believe this? This is also a circle. This is a shifted circle. If this is a circle, then this is a shifted circle where center is at bottom. This is center. This is x-axis. This is y-axis. Consider this height is 1. Then this is the center, that is 0, comma 1 by 2. Equation of the circle is x square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. Y, if it was here, if the circle was like this, then it was x square plus y square equal to 1 by 2 whole square, being 1 by 2 as radius. If circle is shifted like this, then center is here. Then circle equation is x square plus 1 by y minus 1 by 2 whole square equal to 1 by 2 whole square. Y is shifted, offset is provided. Okay, now let's take a polar coordinate in this same thing. Polar coordinate means from the origin where radius will move. So if I take the circle as a polar coordinate is another coordinate where coordinate is in r and theta. This is x-axis, this is y-axis. In that fashion, if I take polar coordinate, if I take it out and behave as a polar coordinate, then there is a radius like this. At the one end of the line will be origin, and other end of the line will rotate at the angle. This is polar coordinate system. So this will rotate. So when angle is 0, radius is 0. When angle is growing, radius is also growing. When angle is 90 degree, radius is 1. When angle is increasing, radius is decreasing. When angle is 180 degree, radius is coming back to 0. This is the how it is. And the way it looks like radius is varying, right? If I have a circle like this, see the difference. If circle is centered at the origin, then if this is the origin, then I move the radius full 360 degree, it makes a circle where radius is not changing. Radius direction is changing, but radius magnitude is not changing. But if I keep center here, and then I move the radius starts with a 0. Then radius is growing if theta is growing. When theta is 90 degree, radius is 90. Radius is full 1. Consider this is 1. Then when angle is growing, radius is finally coming to the 180 degree. Okay, I'm sorry. When radius is making full circle, when angle is going from 0 to 180 degree. Has someone ever tried it? If I have a circle centered at the origin, then circle equation is x square plus y square equal to 1 by 2 whole square. 1 by 2 is the radius. Okay, if I take the circle up, if I move the circle, this is the circle, then I move the circle up, and then this is the new circle now. If this is the circle, then what is the equation of this circle? If I think about polar coordinate system, then radius will start from the origin, and when theta is 0, then there is no radius at all. When theta is growing, radius is growing. When theta is 90 degree, radius is full 1. When theta is growing, radius is decreasing. When theta is 180 degree, radius is 0. With theta going to 0 to 180 degree, it makes a full circle. 360 degree is not required. What is equation of the circle? If it is x square plus y square equal to 1 by 2 whole square. Okay, we have radius and theta is in polar coordinate system. We know that the relationship between Cartesian coordinate system and polar coordinate system is x equal to radius cos theta, y equal to radius sin theta. Okay, if I place x square plus y square at r square cos square theta plus r square sin square theta, it will come at r square. R square equal to 1 by 2 whole square. Radius equal to 1 by 2. Radius is constant 1 by 2. Okay, let's try in the offset circle that is shifted. Let's try here. If that is the case, then it is x square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. If that is the case, then x square is r square cos square theta. I have talked about it once also. Plus y minus 1 by 2 whole square, r sin theta minus 1 by 2 whole square, r square sin square theta plus 1 by 2 whole square minus 2 into 1 by 2 r sin theta. It will become r square theta cos square theta plus r square cos square theta plus r square sin square theta. plus 1 by 2 whole square my, minus r sine theta equal to 1 by 2 whole square. 1 by 2 whole square gone. R square cos square theta plus r square sine square theta become r square theta. R square theta equal to r sine theta. R equal to sine theta. This is the equation of a circle in polar coordinate system. R equal to sine theta. R equal to sine theta. Okay, this is the equation in polar coordinate system circle. Now I'm trying to find the circumference of the circle. What is circumference of the circle? I know 2 pi r. 2 pi where r is 1 by 2. Okay, keep quiet. I know very well. 2 pi r. 2 pi into 1 by 2. So it will come as pi. Let's okay, but you know the formula. How to get the formula? That is another question. How to get the formula? Anyway, now we are talking about parameterization in Cartesian coordinate. Parameterization means I have a circle where what is the position vector of the circle? Consider this is a circle. Circle is like this. If I take a position, I take any point here called x comma y. This is the circle where origin is here. If I take any comma x comma y, the position vector will be xi plus yj, where y equal to a square root of a square minus x square. If I take parameterization means you have to describe everything as one independent variable. Consider x equal to t. Then what will be position vector? Ti plus square root of a square minus t square j. That will be. When t equal to 0 means when x equal to 0, then what is the location of this vector? When x equal to 0, vector is here. That is 0 comma 1. When t equal to 0, it is 0 comma 1. That I have to add now. 0I plus j, that is 0 comma 1. 0I plus j plus ti plus a square root of a square minus t square j. It will come as ti plus 1 plus in bracket 1 plus square root of a square minus t square bracket close j. Means when t is 0, it will come as j here. After that, at t is varying, this position vector will be. This is parametric vector. Makes sense? When t equal to 0, it is j. Otherwise, it will keep changing, the t is changing. This is called parameterization. Parameterization means we have to use a secondary orthogonal component, secondary coordinate system, not the primary coordinate system, to compute our what we want. Here we are taking theta and r as parametric vector. Means instead of, if I'm trying to find the circumference of a circle, whose equation, the equation of the circumference of the circle, is x square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. X square plus y minus 1 by 2 whole square equal to 1 by 2 whole square. What is this? This is equation of the circle for which I have to find the circumference. Let's do parameterization. Parameterization means I have to denote x and y into another component. X equal to r cos theta, y equal to r sin theta. Means if this is xy coordinate where circle is like this, then I will bring another coordinate system called theta r coordinate system. This is theta and this is r. This is theta r coordinate system. If there is a circle in xy plane, then what will be a shape in theta r plane provided x equal to r cos theta, y equal to r sin theta, or r equal to x square plus y square root, and theta equal to tan inverse y by x. Okay, if I talk in that fashion where r equal to sine theta, that is also there. R equal to sine theta, r is not constant. In that fashion, it will make a sinusoidal wave in theta r plane. This is the shape in theta r plane. This is a sine wave. Hope this is a sine wave. Hope this is a sine wave in theta r plane. This is a sine wave in theta r plane. Sine wave in theta r plane means this vertical is r and horizontal is theta. If that is the case, then r is changing if theta is moving. Beginning when theta is 0, r is 0. When theta is 90 degree, r is maximum. When theta is 80 degree, then r is 0 back. Okay, this is what we saw relationship in xy plane between r and theta. So it will be sinusoidal. Okay, if it is sinusoidal, then what is the circumference of the circle? The question is, what is the circumference of the circle in xy coordinate system? If this is xy coordinate system, what is the circumference of circle? This circular circumference is mapped into theta r plane as sinusoidal. If this is theta and this is r, this is theta r coordinate system. This is xy coordinate system. In xy coordinate system, curve shape is circular, where this is the origin, and it moves like this, where radius is half. If same curve, if I take in theta r plane, it will form a sinusoidal, because r equal to sine theta. It will form a sinusoidal. It makes a sinusoidal from where pi goes from 0 to pi. In that form, what is the curve of this 0 to pi? This matching curve, the sine, if this is the sinusoidal, from theta equal to 0 to theta equal to pi, what is the curvature? Mapping to this curvature, what we see in theta r plane, it is circular. Every time I have to do. This is this is this is circular. This is circular in xy plane. Now I have to find the curvature of sine theta. Curvature of sine theta in theta r plane. If this is theta, this is r, then what is the curvature in the theta r plane? That curvature will map here. It will not be the exactly same circumference. Let's divide theta. If there is a line, then we have to divide in only one coordinate system. If I have to find the length of the curve, then I will divide in only one coordinate system. If this is theta and this is r and this is the sinusoidal, if, if this is the sinusoidal, then there are two components here. One is theta that is moving like this, and one is r. R is dependent upon theta. R is not constant. R is if I move in theta, R is also R is, that is vertical. It is also changing. Now, if this is a sinusoidal wave, if this is a if this is a sinusoidal wave, then 0 to pi, I'll chop into n parts. 0 to pi, I'll chop it into n parts. If I chop it into n parts, 0 theta I'm chopping into n parts. If that is the case, theta I am chopping into n parts. If that is the case, then what will be equivalent here? Equivalent here will be, if this is the origin, then radius is moving like this up to 180 degrees. This angle I am chopping into n parts, because theta I am chopping into n parts. Okay, if angle, then if that is the that is the case, then this is first part. Okay, this is second part. This is ith part. If this is ith part, then like that, then this is the nth part. This is ith part. If this is the ith part, where I'm sorry, theta is going 0 to pi only. So this is first part. This is second part. This is the ith part, and like that, then this is the nth part. That's it. Okay, if I take any ith part where we have chopped the theta into n different parts, if I chop theta into n different parts, this is the ith part. If this is the ith part, then this is the circumference. What is the circumference of this ith part? Then I'll sum it for all the parts. Summation I equal to 1 to n. Summation I equal to 1 to n. And where length parameter of the ith part. Summation sigma sine I equal to 1 to n. I equal to 1 to n. And then parameter of the ith section. Then if I add all the parameter, I get what is the parameter of the ith section. Here we will use the length vector. Please watch our previous video how to calculate length vector. Okay, to calculate length vector, if I talk in the polar coordinate system inside Cartesian coordinate system, polar coordinate system inside Cartesian coordinate system. This is Cartesian coordinate system, x and y. Inside that, we have this radius moving in angular fashion. Whereas in theta r plane, this is theta, this is r. This is actually polar coordinate system. But we are trying to push polar coordinate system inside Cartesian coordinate system. So this is x-axis, then this is radius. Radius is moving, then angle is moving. Now angle theta, which was x-axis in theta or coordinate system, it is moving like this in a radian manner, whereas this is the radius. This is how it is superimposed. If that is the case, then if this is ith section, then what is the arc length of the ith section? If I know this arc length of the ith section, then I can add for all the section and I get the result. Okay, then we will use length vector. What is the representation of this arc? If this is the arc, this is the circle. If this, okay, now we are dividing this angle into many sections. Now, this is the ith section. If this is the ith section, this is the arc. What is the length of this arc? If this is ith section, this angle is delta theta. Delta theta. With x-axis, this angle is theta. This is radius number 1. This is radius number 2. See, radius is changing. Here, radius is small. Here, radius is big. Radius is changing. Theta is changing. Both are changing. Both are changing. If both are changing, then what is length of this vector? This is extremely difficult. What is length of this vector? Okay, to get this length of this vector, okay, let's go back to the theta r plane. In theta r plane, we have theta and r. We chop theta into n different parts from 0 to pi. For any ith section, if it is a sinusoidal, for any ith section, if I go up, what is the length? Similar to this. Okay, if I go to the any ith section, means here theta is varying. Here theta is varying. If I go and up, theta is varying. I have taken ith. If I go up and it hits the, every time I have to open it. If it hits the sinusoidal wave above, if it hits the sinusoidal wave above, ith section, ith section, okay, better. Ith section, if I chop 0 to pi into n different parts, ith section will go and hit here. If it hits here, then this is the ith section for theta, where r is also varying. Means theta r is varying. See, r is here, then r is moving like this. Or if I take here ith section, then r is vertical, and here r is vertical. R is varying theta with any theta. So at this point, r is varying, theta is varying. Both are varying. So now we have to focus on calculating the circumference of the ith section in xy plane in such a manner. If I take the any ith section, this is the how it is. This is small and this is big. This is the circumference. If I get the vector representation of this arc, and if I calculate what is the length of any line, okay, tell me the vector representation of that line. Just calculate the magnitude to get the length of the line. If this is x-axis and this is a line that is 0, 0 connecting x comma y, then what is vector representation? What is distance between 0 comma 0 and a point x comma y? Then what is the vector representation? Xi plus yj. X square plus y square square root, that is the magnitude of this, is the length of this vector. All right. Okay, what is length of this vector? 0, 0 to x comma y. Xi plus yj, that is the vector representation. If this is 1 and this is 2, 1 comma 2, 0, 0. I plus 2j is the vector representation. 1 square plus 2 square square root will be the magnitude of this section. What is length of any line between 2 points? Represent it as a vector and calculate the magnitude. Very simple. What is the length of ith section? If I am talking about what is the length of the ith section, represent this as a vector and calculate the magnitude. How to represent a curved line through a vector? This is what we are talking. How to represent a curved line through vector? Representing a straight line through vector is easy. If one point is x1, y1 and another point is x2, y2, the vector will be x2 minus x1i plus y2 minus y1j. This is the vector. What is the length of this section? Is x2 minus x1 whole square plus y2 minus y1 whole square root. Someone can say this is a Pythagoras theorem or something like that. Okay, if I'm successful in representing my arc as a vector, then calculating the magnitude will give the length of this vector. How to represent arc as a vector? To represent any curved line through vector, we have talked about it. If representing a straight line is xi plus yj, for curved line, everywhere y by x, if this is a curved line, if this is x-axis, if it is a curved line, everywhere y by x, y by x, y by x is different. Whereas for a straight line, everywhere y by x is same. So if I want to represent a curved line through vector, the variable component that is y by x must be there. So if it is xi plus yj is the vector representation of a straight line, then I have to take out x so that it will become y by x. What I'm trying to say is, if this is the circle, if this is the origin and this is a curve rather than circle, I would say this is a curve. If this is a curve and this is the origin and this is a point called x comma y, this is the vector will be xi plus yj. But we want vector along the line. That will be the vector that represents the actual curve, not the this vector. Okay, to have that, I should have y by x variable component there. So if I take out x, it becomes I plus y by x j bracket close into x. Division I can place into differentiation, and multiplication I can place into integral calculus. It becomes I plus dy by dx j bracket close into dy into dx. Previous video or previous to previous video, we have explained it in extremely detail how to get length vector. Similarly, if this is xy coordinate system, if this is Cartesian coordinate system, and if I have a ith section in polar coordinates, this is the first section when we chopped theta into n different parts. If this is the ith section, then what is the representation of this arc as a vector? Okay, if I want to represent arc, what you want in polar coordinate system? Yes, in polar coordinate system. In polar coordinate system, any point can be represented. In Cartesian coordinate system, any point is x comma y. In polar coordinate system, any point is radius comma the arc. That is the polar coordinate, not radius comma theta. If it is theta or plane, then I can nominate any point, I represent any point as theta comma r. But if it is a Cartesian coordinate system and this is radius and this is angle is theta, then any point I can represent as r comma r theta, not theta. Because theta is angle, it has to be a distance. Distance will be arc, because when theta is moving, arc is changing. Okay, so r comma theta r. If I make it in vector, it is r unit vector plus r theta unit vector. Okay, it will be the any point. If I connect origin to any point in polar coordinate system that is superimposed on Cartesian coordinate system in radius and an angle manner, any point will be r comma r theta. If I draw a vector, it will be r unit vector plus r theta unit vector. If I try to get the length vector out of it, whatever is the variable, I have to take it out, considering theta is variable, because in theta r plane we drew the sinusoidal wave. Theta is very independent component and r is dependent upon it. So if I want to get the arc vector, I want this arc vector, so that if I calculate the magnitude of this arc vector, I'll get the ith section length. Then I can sum it. Then it is now the vector is r unit vector plus r theta unit vector. I can take out theta. It becomes r by theta, r by theta, r by theta, r by theta, r unit vector plus r theta by theta unit vector, r by theta, r by I'm sorry, r by theta, r unit vector plus r theta by theta unit vector. This is how it will be. Okay. In another, r theta r is constant. That is, if I take arc, considering if I take any arc, considering this r and theta, r is constant at that point. So it is now, it is r by theta r unit vector plus r theta by theta unit vector. If that is the case, then if r and theta are dependent upon each other, now I'm sorry, I'll rephrase it. The actual vector is r unit vector. If I have a point here as origin and another point is r comma, another point is what I'm trying to find out. I'm trying to find out if this is origin, if this point is r comma theta, then what is the vector representation of this arc line? To get the vector representation of this arc line, first you get the vector in polar coordinate system. R unit vector plus r theta theta unit vector. Take out theta from it. Will become r by theta. R unit vector plus r theta by theta theta unit vector. Bracket close into theta. Now make it calculus. dr by d theta. dr by d theta r unit vector plus r theta unit vector into theta into d theta. This will be this is called length vector. This is the length vector that will be along this line. If I am talking about the ith section, if I am talking about the ith section, then this vector representation of this arc is dr by d theta r unit vector plus r theta unit vector. Bracket close into the d theta. This big is the length vector. Means now I can rewrite it. Now what is the full circumference? Full circumference is summation I equal to 1 to n. dr by d theta is not 0. Typically it will be 0 because radius does not change with the theta. If I take typical circle, this is a typical circle where center, this is the center, origin is here, and this is a typical circle. If this is a typical circle, radius will move like this, but radius side will not change. This is typical circle. Radius will move like this, but radius side will not change. But here in this circle, radius is changing. Radius is changing with the angle movement. Radius is changing with the angle movement. Here radius is maximum, radius is changing. With dr by d theta per angle movement, dr by d theta is not 0. But if radius is constant, dr by d theta will be 0. But here it is not 0. Anyway, what is the length vector along the edge? This is dr by d theta. dr by d theta r unit vector plus r theta unit vector, bracket close, d theta. If I talk about the ith section curve, what is the net circumference we are talking? Okay, what is going on? Everything is guided through theta r plane. There is a theta r plane and there is a xy plane. In theta r plane, there is a sinusoidal line, and we have chopped theta into n different parts. For particular theta, I'll try to get the circumference. For a particular theta, I try to get the circumference. Okay, what is the curve length? Similarly, I have mapped it into here. Theta, that is the angle, I have chopped into n parts. Then I am trying to get the arc vector. For the ith section, what? It does not look very smooth. People can think about it. Okay, now if theta is going from 0 to pi and I have chopped into n different parts, for ith part, what is this? Arc length. Whatever is the arc length, we have the full arc length, that is the parameter of the circle when theta is going 0 to pi. Parameter of the circle is summation I equal to 1 to n. Length of the ith section, parameter of the ith section. Parameter of the ith section is the magnitude of this length vector. Length vector is dr by d theta r unit vector plus r theta unit vector. Its magnitude means dr by d theta whole square plus r square, a square root, into d theta. What is dr by d theta? Delta r by delta theta. Delta theta is delta theta I. Delta r is actually, when we do the circle, r, this is the r1 and this is r2. r2 minus r1 in the ith section, if I talk, this radius and this radius are different. r2 minus r1 is delta r. Delta r by delta theta. If I move delta theta, how much r is changing? Okay, dr by d theta or delta ri of the ith section, what is the change in radius I am seeing? By delta theta I, how much delta theta is? Delta r by delta theta, delta ri by delta theta I whole square plus r whole square. Okay, r is the first r, not this r, first r whole square, because This position what we have taken, that is from the base, this radius. So r r1 or r whole square root into delta theta I. This is delta theta I. This is expression that exactly matches to function over theta and r. What do you mean? Consider now what we have seen now. What is the circumference? Summation I equal to 1 to n square root delta r r by delta theta I, delta r I by delta theta I whole square plus r whole square root into delta theta I. If I sum it for I equal to 1 to n, I'll get the full circumference. Okay, now let's make n tends to infinity. If I make n tends to infinity, to convert into integral calculus, because this is very difficult to sum it. Delta r I by delta theta I whole square plus 1 square root delta theta I. It is impossible to calculate I equal to 1 to n. What is n? N should be something. Let's make n tends to infinity. If n tends to infinity, the chopping I am making tends to infinity, then delta theta I tends to 0. If I have delta r by delta theta tends to 0, it will become dr by d theta as per the first principle of calculus. Now it will become a square root of dr by d theta whole square plus r square. Dr by d theta whole square plus r square. D theta. Integration 0 to pi. Theta is varying 0 to pi. If someone calculate it, he will get the circumference of the circle. Is it really true? Yes, it's true. Summation 0 to pi square root of dr by d theta whole square plus r square d theta. If someone calculates, then he will get the circumference of the circle. What is r? R equal to sine theta. Dr by d theta is cos theta. Cos square theta plus r square. Cos square theta plus r square. R is sine theta. Cos square theta plus r sine square theta square root 1. Only d theta will remain. D theta integration is theta. Theta 0 to pi. Pi is the circumference of the circle. Indeed, pi is the circumference of the circle whose radius is 1 by 2. 2 pi r pi. Same thing. Okay, this is something called parameterization. Whatever we are trying to calculate, we brought up another component called theta, and we brought theta sidewise. This is xy coordinate where I have problem. I dedicated this problem, or I delegated this problem to theta, that is the third party component. And we brought theta r plane, xy plane, theta r plane. In theta r plane, I cut down the theta, considering theta is the independent variable. Then I mapped to the sine wave, and there I am trying to see the magnitude. Same thing I did in the circle, theta I cut it, because if I want to calculate the circumference of a circle, the circumference is matching to sinusoidal line. What is the length of sinusoidal line? Its map is here. For that, I cut theta into n part. A particular theta, ith section, I try to get the length of this. Then I sum it for I equal to 1 to n, I get it. Similar thing I did here. Okay, to get it, I get the arc of a circle. That arc of a circle I represented through the length vector. Okay, length vector came as dr by d theta, considering r is variable with the theta. Length vector started with r comma r theta. Like if I talk about length vector in xy plane, it will start with xi plus yj, then I plus y by xj bracket close into x, then it will be I plus dy by dxj bracket close into dx. This is the length vector. If you calculate magnitude of it, you will get the length of the any curved line. Similarly, in polar, it is theta. It is r comma theta r. If it is in xy coordinate system, if I have taken theta r coordinate system, then each point is theta comma r. Theta unit vector plus r unit vector. But if I take xy coordinate system, and there if I talk about polar coordinate system, then any point will be r comma theta r or theta r comma r. Then the position vector will be r unit vector plus theta r theta unit vector. I have to take out independent component here. Then it will become r by theta r unit vector plus r theta by theta unit vector bracket close into theta. Convert into calculus. It will become dr by d theta r unit vector plus r theta unit vector, bracket close d theta. If someone is taking ith component, the way we took ith component of the angle, then r is delta r. What is delta r? This is something that is not mentioned in any of the book. What we are talking. Length vector is also not there in any of the book. If this is x axis, this is y axis. If this is radius is going like this, then we are talking about ith section radius. This is the probably this. If I cut this angle into n different parts, this is the first part. Then this is the second. This is the second part. We are talking about any ith part. If I talk about any ith part, radius is varying. This is theta angle with the x-axis. This is delta theta. Delta theta, if this is ith section. If I chop this full 180 degree into n section, this is ith section. This angle is delta theta I. If this is R1, then this is R2. Both are not same. They are different. In that fashion, if I say my length vector is dr by d theta, r unit vector plus theta unit vector. If this is bracket close into d theta, then dr by d theta is equal to delta r by delta theta. This is delta theta and this is delta r. If this is r1 and this is r2, then delta r is r1 minus r2 or r2 minus r1. So actually the length vector is delta r of the ith section by delta theta of the ith section, r unit vector, plus r, any r I can take. This r if I take r, this r I have to take because we have taken this point for the curvature. R theta unit vector. Okay, bracket close. I'm sorry, r theta unit vector. Bracket close into delta theta I. If I take the magnitude of this vector, then it will be delta r by delta theta whole square plus r square. If I was saying somewhere 1 square plus r square. Delta r by delta theta whole square plus r square root into delta theta. This is the ith section length vector length. Now I have to sum it for all the sections. If I make n tends to infinity, the delta theta will become tends to 0. Delta r by delta theta tends to 0 will become dr by d theta. And delta theta outside will become d theta. Dr by d theta is cos square theta. R square is sin square theta. Square root 1 d theta integration theta. Theta is 0 to pi. 0 to pi only, not 2 pi. Pi. Pi is the circumference of the circle. Okay, this is called parameterization. Shifting our problem domain into third party, that is called theta, and try to solving into theta r plane, and accordingly I solve into xy plane and solve the problem. We will do more in the parameterization. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone. +91 is the India country code 9483160610 is the telephone.